Welcome to the channel. We have to find out the gain of the amplifier. Here, I have drawn in general circuit where I mention R1, R2, R3 and R4 resistors and also the direction of current. So let's start. First assumption, according to the virtual ground concept. In this case, non-inverting terminal is connected to ground and therefore, according to the virtual ground concept, Vx voltage this is equal to 0. Now apply KCL at Vx node. Here I am applying KCL at Vx node. Summation of incoming currents is equal to summation of outgoing currents. I1 is incoming current, which is equal to I2 is outgoing current. Now, put the values of I1 and I2 in terms of voltage and resistor. This is Vi minus Vx by R1 and I2 is nothing but Vx minus Vz by R2. Vx minus Vz by R2. Apply the KCL rule here at Vx. I1 is incoming current, I2 is outgoing current. So Vi minus Vx divided by R1 and I2 is nothing but Vx minus Vz divided by R2. Simplify this equation. So from equation 1, Vx is equal to 0. What I am getting, Vi by R1 is equal to minus Vz by R2. Since Vx is equal to 0 according to virtual ground concept. Find out the value of Vz. So what I am getting, minus R2 upon R1 into Vi. Say this is equation 1. Now apply KCL at Vz. For condition, KCL at Vz. I2 is incoming current, which is equal to the summation of outgoing currents, which means I3 plus I4. Putting the value of current. So I2 is the current, which is the difference of Vx minus Vz. Vx minus Vz divided by R2, which is equal to I3 is the current, which is simply Vz by R3. Vz by R3. The same way, I4 is Vz minus V out divided by R4. Vz minus V out divided by R4. As we know that Vx is 0, so first root Vx is 0, then what we are getting, minus Vz by R2. This is equal to Vz by R3 plus Vz minus V0 by R4. But according to the equation 1, the value of Vz, which is equal to minus R2 upon R1 into Vi. In the above equation now, taking Vz terms to the one side, so we are getting minus Vz by R2 minus Vz by R3 minus Vz by R4. This is equal to minus V0 by R4. Taking minus sign common on both sides, so term will be positive, and also taking Vz common. So what we are getting, 1 upon R2 plus 1 upon R3 plus 1 upon R4. This is equal to V0 by R4. Now we can put the value of Vz in this equation, which is equal to minus R2 upon R1 into Vi. So this is minus R2 upon R1 into Vi in bracket into 1 by R2 plus 1 by R3 plus 1 by R4, which is equal to V0 by R4. After solving this equation, what we are getting, the gain, which means that gain is equal to V naught by Vi, which is equal to minus R2 upon R1 in bracket into 1 plus R4 by R2 plus R4 by R3. Say this is equation 2. Now coming to the solution. Therefore, gain is equal to minus R2. The value of R2 is 15 kilo ohm divided by R1 is 1 kilo ohm. So the ratio of R2 and R1 will cancel the kilo ohm. So directly we can write 15 by 1 in bracket into 1 plus R4 value is 15 kilo ohm divided by R2 value is again 15 kilo ohm plus R4 15 kilo ohm divided by R3 is 1 kilo ohm. So what we are getting, that is equal to, this is minus 15 only in bracket into, we are getting 1 plus 15, which is equal to minus 15 into 17, and which is equal to minus 255. And therefore the gain of the amplifier in this circuit is minus 255. This is the solution of this problem. Thank you.